Okay, welcome everyone to ME 3311 Material Science for the first summer session of 2020. That will last from first day of class is June 2nd. Last day of class will be July 1st, with the last exam being either July 2nd or July 3rd. I'm not sure exactly which one yet, but so that's the length of time that the class will be going. We will supposedly, since this is an online schedule, we will be having classes essentially every day, or at least material being presented every day. It'll be fast and furious, that's for sure, with that short a time frame, and so we'll do the best we can to get all the information out there to you. It'll be very basic information because there's not a lot of time to expand on a lot of things necessarily with this online session type of format. But at any rate, what I've got in front of you here is the syllabus for 3311 Material Science, and I'll tell you, like I tell all of my 3311 classes first day, and that is the fact that ME 3311 is without a doubt the most important class you will take at Texas Tech University. And I say that without any due questions, because if you think about it, everything you do eventually as a mechanical engineer usually involves producing something, some component, some assembly, some device, some machine, some vehicle, etc., 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 which of course will all be made out of some type of material. So it's very important to have worked up what I consider to be a material repertoire or a material inventory that you can look at and have a good idea and a good selection criteria necessary to choose the correct material for that particular application. So that's what this is all about. And we'll go over the syllabus just briefly here. The first thing down here is talking about the grading, and this has changed a little bit because of this online sessions. We will have 5 exams. There will be no comprehensive final exam, though, however. We will have 5 exams, 5 topic exams that we'll go over what those topics are. Now, these exams, what I like to call celebrations of learning, essentially, if you look at the calendar, we'll probably have approximately one every week, either at the beginning, at the end of the week, or the beginning of the next week, depending upon the schedule, how it goes. But approximately, again, about one every week at the end of the week or at the end of the discussions of those topics. Now, again, this could be This could change a day or two, depending upon how it goes. This is all, of course, uncharted territory. Not only with respect to the online part, but for the summer session, this has really never been done. So we're all going to be learning together on this, but we'll make it work somehow. So now, if you look, and you will have already received this syllabus, will have emailed it to you, so you can take a look at that. But let me go over these, particularly this second page of the syllabus, and let me put up some copies that are a little bit more legible as far as the font size goes here. And let me get these kind of aligned so you can see them. All right. Okay. So, essentially what we've got here is the topics and exams. Now, so these are the topics we're going to cover, these 4 areas before our first exam, which will probably, since we start technically on Tuesday, probably maybe around Friday. But we'll talk about the atomic structure and interatomic bonding. Then we'll shift to the structure of crystalline solids, and then what we call imperfections in solids, because nothing is completely perfect inside those crystalline lattice sites. And then we'll talk about this wonderful process known as diffusion from a solid state perspective. Now, this whole entire course is based on solid state chemistry. We don't deal that much technically in liquids, gases especially. We do deal with some liquids once we get into phase diagrams and actual metals and melting points in liquids and solids. But anyway, so then we'll have a first exam. Then we'll do mechanical properties of metals, which is very, very fundamental with respect to your overall perspective in mechanical engineering. This is the language, this is our vocabulary that we talk. This is how we communicate through these mechanical properties. And we'll be going through those properties continuously as we go throughout the rest of this session. And then we'll talk a little bit about ways we can strengthen different alloys, different metals, using different types of strengthening mechanisms, and one of which is referred to as dislocations. And then we'll talk about failure, because most things occasionally do have a tendency to fail, and so we need to understand why and how that failure occurs and how we might minimize the effect of a potential failure, let's say. Okay, and then exam 2 will be after those 3 topic areas. And then we'll get in and we'll spend an entire sessions on phase diagrams. Very important fundamental body of knowledge within material science regime is the understanding of phase diagrams. We'll talk about 2 or 3 different types of phase diagrams, and ultimately get into the most important one that you'll be dealing with primarily will be the iron-carbon phase diagram, and go through all of those. And then we'll have an exam just on phase diagrams, which would be exam 3. And after that, we'll go into a little bit of how we transform some of these phases, how we can push the properties a little bit differently, and the development of different microstructures on how we do that. And as a result of these transformational changes to the microstructure, we actually alter the mechanical properties of those alloys, those metals. And so we'll look about that. And then a lot of that is involved in heat treating, which we'll talk about this on this last section here called applications. We really don't talk about processing of metals and alloys, but that was the title of a chapter in the book. And you can look at your syllabus, and there are 2 books pointed out there that you could possibly use as a reference. I don't teach directly out of those texts, but they're wonderful references if you'd like to look through those. But at any rate, we'll go through heat treating in that section as well. Then we'll have an exam just on these areas here, these 2 areas, which are phase transformations, and then the applications and processing, which is essentially talking about the different metal alloys, and also talking about the heat treating processes. Okay, so, and then we'll have that exam 4. And then the last topical area we're going to discuss, we're completely shift gears and talk about polymers and plastics and composites. So we'll spend time talking about polymer structures, the chemistry about the polymers, some characteristics, some applications, and the processing of some of these polymers. And then we'll talk specifically about polymer matrix composites, or PMCs, which is a very, very new type of a material system that is being utilized in many, many, many different applications nowadays. So we'll talk about composite structures, and then we'll have our last exam on that July 2nd or July 3rd. Okay? Now, the structure of this, again, this is all new for the summer, doing it this way. So, but I will attempt to deliver specific topic material via what I call Whiteboard Lectures, and I'm going to show you a whiteboard here in just a moment, that have all been video recorded, and I will forward those to you vis-a-vis a link of some sort. And then once you look at these videos of the lecture material that has been covered, I will then try to have a Zoom session with everybody where you'll be able to ask questions over the material that I have covered or presented prior to an exam. So we'll have kind of an open discussion. If we can make all that work, which I think we can, because now I have a camera. I didn't have one last semester because they ran out, but I do have one now, and I think we can make that work. So we will have a Q&A session before an exam, so we can cover some things if you have some questions. Okay, the rest of these kind of the rules of the road kind of thing. Here on the exams will all be administered via Blackboard and the associated formats that Blackboard has for exams. Essentially, multiple choice is what we did last semester, which was a big change. But at any rate, now all the exams are to be taken without the use of any supplemental resource, including notes, videos, books, etc., just like you were in the classroom, without any notes. And the other thing is, you need to understand that the exams will start at a specific time that you'll know ahead of time, of course, what that is, obviously, and you will have 1 hour and 15 minutes to complete the exam. All right. So that's how the actual structure of the exams will be when we do get started, and you will know, like I said, that first week, you will know probably again that may have one at the end of that first week on that Friday, perhaps, or again maybe a day or two, or a day ahead of time, or a day behind, depending on how it goes. But it would expect to be a day ahead of time, if anything. But okay, so that's the basic overall structure of the class. If you have any questions regarding the structure of this class, in the meantime, in the interim, you can email me those questions you might have. But that's basically how this thing is gonna run. Okay, so now what I do is that before every one of those topic areas that we talked about in the syllabus, I give you a list of important terms and concepts, okay, that I will be covering. Important terms and concepts. Let me refocus the camera here. All right. Get this where you can see all this. Okay. So, this is what we're going to be covering on this first session, and what is entitled Atomic Structure and Bonding. So these are the terms and concepts that I'm going to be trying to cover, and which will be covered on the first exam. And so these are just basically in alphabetical order as best I could, starting off, of course, with the atom. Again, the atomic number, sometimes referred to as proton number. Then the bonds, of which we have covalent, ionic, and metallic bonds that we'll talk about. And then we'll start with the subatomic particles like the electron, the proton, the neutron. We'll talk just generally about what those are. But the most important one of those really is the electron, because this is what is involved in all bonding operations. Is the electrons, which goes down here to what we refer to as the valence electrons, the ones in the outermost shell. But then we'll look at what the electron configurations are for each element and how those are determined. Electronegativity is also very important. We'll talk about its concept and how again it involves the actual bonding as well. Electronegativity plays an important role in that with the electrons. Now, ions are something that are a net neutral charged atom. They don't all have to be. Ions are not net neutral, is what I should say. Ions are not net neutral, where the electrons and the protons equal each other on as far as the charge goes. We do have negatively charged ions and positively charged ions, and we'll go through those. And then, of course, we have with respect to electronegativity and the ions, of course, the ionic bond, isotopes, talk about what those represent. Then the metallic bond, finally, that's the timer for 15 minutes, just so I know. And then we'll talk about metallic bonds, which we'll be dealing with mostly because that's what we're going to be dealing with, crystalline structures and metal alloys. So we'll talk about what that represents. A little bit different from the structure as far as the covalent and ionic bond. Metallic bond's a little bit different. Then, of course, again, talking about the interatomic, here's the nucleus, the neutron. Then we'll talk a little bit about the periodic table, what that represents, and what a wonderful tool that can be. And then the proton, and then finally, as I mentioned to you, the valence electrons, or what we call the valency. So those are the basic terms and concepts that I'll try to cover for you in these whiteboard lectures. Now I'm going to break it down into 3 basic topic areas. First, we're going to start off with this atomic structure fundamentals. I have made a handout, and I will have already emailed that to you, so you'll have a copy of that. We'll go through that first, and then we'll talk about basic elements and the periodic table, a little bit of history about the periodic table, but how the elements are arranged in the periodic table and what they mean, and what a useful tool this can be. And then finally, the different bonding types, the essential fundamental primary chemical bonds, which again are the covalent, ionic, and metallic. So that's what we're going to be covering, and stay tuned for the second video, which will start talking about the atomic structure fundamentals.